Have you ever felt like there's, a hidden layer to reality, something deeper running underneath everything we can easily see?
Like a different kind of physics, maybe.
Exactly. Maybe even a 0 point that isn't actually empty at all, but
Uh,
while full of potential. It's a pretty wild thought,
it
right?
is. And today we're diving into a paper that doesn't just suggest that. It builds this really rigorous new framework for it.
A framework to explain why that hidden layer might exist and how it could actually, rise to everything else.
That's the plan. Our mission here is to really unpack Philip Lillian's paper, from ad hoc mechanics to generative ontology, reconstituting the foundations of scalar physics through the bivector formalism. It's quite a title.
It is. So we're going to break it down, look at the core arguments, get a handle on this bivector coherence formalism he proposes.
And really explore why it's potentially such a revolutionary way to look at fundamental physics.
Right. We'll be your guides through this. It gets pretty deep, but it's fascinating stuff. And the goal for you listening in is to walk away really getting the shift this paper proposes.
Yeah, it's a shift from just describing what the universe does to trying to explain why it does it.
All by taking a really hard look at what nothing, or this 0 point, actually means.
Okay, so to really get what Lillian's doing, we first need to understand there are kind of two different ways people have talked about scalar fields. They often use the same term, but mean quite different things.
That seems like a crucial place to start. So what's let's say, the standard physics view? How does conventional physics see a scalar field?
Well, in standard physics, it's actually pretty straightforward. Think about like a weather map showing temperature.
Okay, yeah. Different values at different points.
Exactly. A scalar field just assigns a single value, a magnitude, like temperature or pressure or maybe density, to every point in space. No direction involved, just a number.
Unlike a vector field, like wind, which has direction and speed at every point.
Precisely. It's just the magnitude. And here's a key point for later. In this view, if you have two forces pulling against each other perfectly.
Like a tug of war.
Yeah, exactly. If they pull with equal strength in opposite directions, they cancel out. The net vector, the overall force, is zero.
Makes sense. Nothing moves.
Right. But the scalar field associated with that situation, say the potential energy stored in the stretched rope, or maybe just the tension itself, that doesn't necessarily vanish or neutralize.
Ah, okay. So the forces cancel, but the potential, the scalar value, can still be there.
It can still carry stored potential. The scalar value representing the state of tension is still non-zero, even if the directional forces sum to nothing.
Okay, I think I get the conventional view, but then there's this other perspective, right? From people like Keeley, Tesla, Bearden. They used scalar field differently.
Very differently. And their thinking often revolves around a specific device or concept, like the bipolar coil.
Right, I've heard of those. Two wires wound together.
Yeah, often side by side. And the idea is, if you run currents through these two windings that are exactly equal in strength but flowing in opposite directions,
Okay.
then, remarkably, their external electromagnetic fields, the kind we usually measure, the transverse waves, they effectively cancel each other out.
So from the outside, it looks like nothing's happening. No radio waves, no magnetic field you can easily detect.
Pretty much. Externally, it seems quiet. But, and this is their big insight, they proposed that even though the external fields cancel, there's still an internal tension or stress left behind.
Where? In the wires themselves.
Within the dielectric material, the insulator between or around the wires. They believed a potential exists there, a kind of hidden stress field, even without any detectable vector radiation.
Okay, so like compressing a spring evenly from all sides. It looks still, but it's full of stored energy.
That's a good analogy, yeah.
Yeah.
They called this hidden stress various things: scalar potential, longitudinal potential, sometimes even ether compression.
Ether compression. Okay.
Yeah.
So for them, canceling the vectors didn't mean emptiness.
Not at all. It created what they saw as a latent 0-point state, a reservoir of stored potential, hidden from normal detection methods, but fundamentally there.
So Lillian's paper jumps right into this difference, doesn't it? How conventional physics sees zero force as just, well, zero, while these other thinkers saw it as something full of potential.
Precisely. It highlights that fundamental divergence in understanding cancellation and zero. And that perfectly sets the stage for introducing the bivector coherence formalism.
Oh, right, because that formalism aims to give a solid, ontological basis for this idea of a structured zero, doesn't it?
Exactly. It tries to bridge that gap we just discussed.
Okay, so we've got these two clashing ideas about what happens when things cancel out. How does Lillian's bivector coherence formalism step in? What even is a bivector in this whole picture?
Right, so the paper introduces the bivector not just as like a mathematical object, but as a fundamental structure of coherence. And it has this really interesting dual nature.
Dual nature, how so?
Well, think of it having two key sides. First, there's what the paper calls internal continuity.
Yeah.
This is like a deep, conserved, continuous spin coherence, an unbroken order that just persists internally.
Like an inherent hum or spin that's always there underneath everything.
Sort of, yeah. It's conserved. And the second aspect is its external decomposition. This is about the discrete states that pop out when the bivector's underlying symmetry gets reduced or broken.
Like spin up and spin down in quantum mechanics?
Exactly like that. Or opposing forces. These distinct states we measure externally are seen as projections or breakdowns of that deeper, continuous internal coherence.
Okay, so this must be where the bivector 0 point comes in. When those external things spin up, down, opposing forces cancel out.
Yeah.
The coherence isn't actually gone.
That's the absolute crucial insight. When the external vectors sum to 0, the coherence is not destroyed. It's just, well, it's conserved internally within the bivector structure. It pulls back, so to speak.
So the 0 we measure externally isn't emptiness.
No. It's a structured potential. It's that internal coherence, hidden from view but still there, a latent reservoir. Like that still pond analogy, calm surface, powerful currents underneath. That's the bivector 0 point.
So it sounds remarkably similar, conceptually at least, to the Keeley-Tesla idea of the biflare coil canceling external fields but leaving internal tension.
The parallel is definitely there. That internal vibratory stress they talked about aligns really well with the idea of persistent internal bivector coherence when the external vectors cancel.
But Lillian's framework gives it a mathematical backbone. It moves it from an observation to something more fundamental.
Exactly. It aims to provide the rigorous ontological why. It takes it out of the realm of, potentially unexplained phenomena and grounds it in fundamental structure.
Okay, so let's dig into that comparison the paper makes. Neutralization in the Keeley SVP sense versus the bivector 0 point. How do they stack up?
Well, in the Keeley or sympathetic vibratory physics, SVP view, neutralization is seen as this special process where opposing polarities like positive and negative, or maybe compression and rarefaction, they resolve into a kind of neutral center.
And they didn't see this as just cancellation, right?
No, they saw it as a return to a latent potential, a quiescent state, but a powerful one. Not destruction, but a kind of reabsorption into the source.
And the bivector formalism, it formalizes that idea.
It does. It provides the mathematical structure.
Yeah.
When external vectors cancel, the internal bivector coherence is conserved. Measurement might show 0 externally, but the potential isn't annihilated.
So both frameworks agree the 0 point isn't empty.
Yes, both see it as a reservoir of coherence or potential. The key difference Lillian argues for is that the bivector framework offers a more rigorous ontological explanation. It derives it from first principles, rather than just describing an observed effect using perhaps more esoteric terms like ether.
Right. And this grounding in first principles, it goes really deep, doesn't it? The paper talks about a hypergravity seed and starts with 0 equals 1. That seems almost philosophical.
It is deeply philosophical, but presented as foundational mathematics. The paper posits this hypergravity identity, 0 equals 1, as the absolute invariant source, the bedrock of reality.
0 factorial equals 1. How is that a source?
It's interpreted not just as a mathematical convention, but as a statement asserting the existence of a fundamental unit element, what the paper calls a scalar zero form. Think of it as pure, undifferentiated potential, a dimensionless point of unity from which all structure arises. It's the unmanifest source.
And the bivector. That's the very first thing to emerge from this unity.
That's the argument. The bivector is the first act of ontological differentiation. It's the first step away from pure invariance. And crucially, it does two things. It maintains that internal continuous spin coherence, the scalar neutrality, while also holding the potential to split into discrete external vectors.
So it's like the bridge between pure unity and the differentiated world we see.
Exactly. The first identity appearance, as the paper puts it, where neutrality and the potential for distinction coexist.
And this isn't just plucked out of thin air. The paper argues it's mathematically necessary.
It emphasizes its mathematical inevitability. There's a proposed minimal derivation path. Start with the unit from 0 point. Introduce the first fundamental split like positive-negative. Then crucially apply the principle of antisymmetry, meaning swapping them reverses their relationship.
Okay.
That naturally leads to the bivector as the minimal structure needed to capture the relationship or coherence between those two initial directions. It's like defining an oriented area between them.
An area.
In an abstract sense, yes. It captures the ordered relationship. And once you give this bivector structure a metric, a way to measure distance or magnitude within it, it inherently becomes the generator of rotation and spin. So it's presented as emerging unavoidably from the most basic mathematical principles applied to that initial unity. Not an invention, but a discovery of inherent structure.
Wow, okay. That really grounds it. So with this bivector structure established, how does it change our view of things like wave dynamics? Some of those SVP ideas like phase conjugation seemed pretty mysterious.
Right. Lillian uses the bivector formalism to reinterpret 3 key SVP interaction modes. The goal is to show they aren't weird, unexplained effects, but actually natural, inevitable dynamics of how this bivector coherence behaves.
Okay, let's take them one by one. First up, antiphase. That's basically destructive interference, right? Waves canceling out.
Yeah. In the SVP view, when waves meet perfectly out of phase, crest to trough, you get destructive interference. They sometimes describe this as like an entropic dissolution order dissolving into seeming nothingness or chaos.
Look like information loss. How does the bivector see it?
The bivector reconstitution says, yes, the external vectors sum to 0. You see cancellation, maybe what looks like entropy. But internally, the bivector coherence persists. It's not destroyed, it's just hidden from external view.
So the order isn't gone, it's just withdrawn.
Exactly. It appears as a loss of signal externally, but the underlying coherence is conserved internally. What looks like decay is just coherence pulling back its external expression.
Okay. What about the next one? Phase conjugation, the time reversal wave thing.
SVP saw this as quite remarkable, a wave that retraces its path, undoing distortions, restoring coherence. They called it syntropy, the opposite of entropy, almost like self-healing.
Seemed almost magical, the bivector explanation.
It's framed as the internal bivector spin coherence, actively reasserting itself. When the external wave gets distorted, the bivector's conserved internal coherence acts like a template or a restorative force. It feeds back to correct the asymmetry and restore the original coherent form.
So it's not time travel, it's the underlying coherence pushing back towards order.
Precisely. It's the inherent self-organizing property of the bivector structure, actively correcting deviations to maintain its coherent state.
Makes sense. And the third one, neutralization. SVP considered this the most powerful.
Yes, they saw it as more than just cancellation. It was opposing forces resolving into a perfectly balanced, quiescent neutral center, a return to the latent source potential, the 0 point, a state of immense untapped power.
Which sounds very much like the bivector 0 point state we talked about earlier.
It maps perfectly. In the bivector framework, neutralization is when the bivector structure collapses back fully into its pure internal coherence mode, its continuous spin state, its meta-operator potential.
The generative source.
Exactly. The deep internal reservoir where coherence is conserved in its purest form, ready to project new vectors, new forms. It's the ultimate state of potentiality.
So the big takeaway here is that these three modes, antiphase, phase conjugation, neutralization, aren't separate mysteries. They're just different ways the underlying bivector coherence expresses itself, either hiding, actively correcting, or returning to its source state.
You've got it. They become different facets of the same fundamental coherence dynamics, predictable outcomes of the bivector formalism, not just weird observations. It gives them a solid place within physics.
Now, another area where physics seems, well, a bit fragmented is the whole concept of spin. Quantum spin, internal spin, external spin, color charge, chirality. They all use the word spin, but seem totally different.
That's a huge point the paper tackles. Mainstream physics does treat these different kinds of spin largely as distinct phenomena, often with their own separate mathematical descriptions and theories.
Can you quickly recap those different spins?
Sure. You've got quantum spin, usually described as intrinsically up or down, a binary property with no real classical counterpart. Then there's the difference between that intrinsic spin and orbital angular momentum, which is more like external spin, an object revolving around something else.
Okay.
Then in particle physics, you have chromodynamics spin related to the SU3 color charges of quarks in the strong force. And you also have chirality, or handedness, which is crucial for understanding the weak source. They all seem quite separate.
But the bivector formalism claims they're all connected, all just different views of the same underlying thing.
That's the core thesis here. It proposes that all these differentiated spin states are simply reductions or projections of that single fundamental bivectorial coherence structure.
Okay, how does that work for, say, quantum spin? How does up-down come from a continuous bivector?
The idea is that the up and down states we measure aren't fundamental in themselves. They're what we see when the bivector's internal continuous spin coherence is forced to project onto our measurement axis. The measurement forces a binary choice from a deeper continuous reality.
Like seeing only black or white when the reality is a full spectrum of gray.
A good analogy. The binary nature is an artifact of observation, a projection, not the fundamental state.
An internal versus external spin.
Also just different projections of the same underlying bivectorial structure. How that coherence manifests depends on the context, whether it's localized intrinsic rotation or broader orbital motion. It's the same source viewed differently.
What about the really different ones, like color charge or chirality?
Same principle, just more complex projections. Chromodynamic color charges, SU3, are seen as triadic decompositions of the bivector coherence. Instead of splitting into two, like spin-up-down SU2, it splits into three resonant states.
So like a more complex chord derived from the same fundamental note.
Exactly. And chirality, or handedness, is seen as another projection, expressing an inherent phase asymmetry or twist that arises when the bivector's symmetry reduces.
Wow. So what seems like a whole zoo of different spins could actually be unified. For you listening, this is huge. It suggests that phenomena we treat as completely separate in physics might all stem from one single, deeper source, this bivector coherence. It offers a path to simplifying our picture of fundamental reality.
It really does. It tackles that conceptual fragmentation head-on, aiming for a much more unified and, frankly, elegant foundation.
Okay, we've explored the bivector concept, how it reinterprets waves and unifies spin, but the paper really drives home a core argument, contrasting ad hoc mechanics with generative ontology. What's the essence of that distinction?
This is where Lillian really lays out why the bivector coherence formalism isn't just another model, but a fundamentally different kind of explanation compared to, say, the Keeley-Tesla-Bearden approach to scalar phenomena. He uses a comparative ontology matrix to make the differences really stark.
Let's walk through that first point, the origin of scalar. How do the two views differ?
In the Keeley-Tesla-Bearden view, remember, scalar potential is basically a byproduct. It only appears when you arrange vectors, like currents in a bifilar coil, to cancel each other out. It's an effect, not a primary cause.
It has to be generated by canceling something else first.
Right. But in the bivector model, scalar isn't a byproduct. It's intrinsic. The internal coherence is always there within the bivector structure before anything cancels externally. So scalar coherence is presented as a first-order ontological constant, the source, not a second-order effect.
Okay. And the nature of scalar itself, Keeley-Tesla saw it as residual stress or hidden potential.
Yeah, often described in those terms, maybe linked to an ether. It's a description of what it feels like or what it might be, but lacks a precise structural definition within fundamental physics. The bivector model defines it specifically as the zero-point coherence mode, the internal continuous spin that precedes and generates the vectors we observe. It's the engine, not the exhaust.
This difference leads straight to their ontology, their fundamental theory of reality, right?
Absolutely. The Keeley-Tesla-Bearden model is fundamentally descriptive and phenomenological. It describes interesting effects, but doesn't fully ground them in first principles or explain their ultimate origin. This, the paper suggests, leads to its somewhat cult status, compelling observations without full integration into physics.
Whereas the bivector model aims to be
Generative and structural. It aims to derive scalar neutrality and its consequences from the most fundamental principles of coherence, tracing it back to that 0.1 identity. It explains how it comes to be, not just that it is.
How about their connection to established physics?
The Keeley-Tesla-Bearden ideas often use language like sympathetic vibration or ether mechanics, which doesn't easily connect to modern concepts like gauge theory, tensors, or the standard model. There isn't a clear mathematical bridge.
But the bivector model is designed to integrate.
Yes, it's explicitly framed in terms of symmetry reduction, coherence tensors, and the emergence of the known gauge groups, U1, SU2, SU3. It attempts to root scalar phenomena firmly within the mathematical language of modern physics, showing how these fundamental forces could emerge from it.
So wrapping up this comparison, completeness and generativity, Keeley-Tesla looks like.
The paper argues it comes across as ad hoc mechanics, a clever trick or observation that works in specific setups but doesn't offer a universal generative principle. Useful, perhaps, but partial.
And the bivector model offers.
What Lillian calls satisfying structural completeness, because phenomena like cancellation, phase conjugation, and neutralization all naturally emerge from the formalism itself. It's presented as a universal principle applying from quantum scales to cosmology. Not just a trick, but a fundamental law.
So the absolute core distinction boils down to Beer and Keeley see scalar potential as a trick of mechanics that appears when vectors cancel.
While the bivector UCTE, Unified Coherence Theory of Everything, sees it as a law of ontology, the hidden coherence reservoir from which vectors emerge in the first place.
That's a profound difference. It really reframes everything, moving scalar from a curiosity to potentially the very foundation.
That's the claim, a complete reconstitution of scalar physics.
Okay, this shift from mechanics to ontology has massive implications. Let's explore those for fundamental physics, starting with something central like gauge symmetry. How does the bivector change how we view U1, SU2, SU3?
Conventionally, as we've touched on, these gauge symmetries are sort of foundational postulates in the standard model. They work incredibly well to describe electromagnetism U1, the weak source SU2, and the strong force SU3, but why these specific symmetries govern reality isn't fully explained. They're inputs to the model.
Just how things are.
Pretty much. But the bivector framework proposes something radical. These symmetries are not arbitrary givens. They are natural, inevitable decompositions of the underlying scalar coherence.
Decompositions? How?
The idea is that the bivector's internal coherence represents a state of perfect, undifferentiated order, a hypersymmetry. When this hypersymmetry undergoes coherence reduction, it doesn't just vanish. It splits or differentiates into structured modes. And these structured modes are the gauge groups we observe.
So U1 is one way the coherence breaks down, SU2, another, SU3, yet another.
Exactly. U1 emerges as the coherence reduces into electromagnetic phase relationships. SU2 appears when it reduces into binary states like spin-up-down. SU3 arises from a more complex triadic decomposition related to color charge.
Sure.
The huge claim is that all gauge groups are simply different asymmetry reductions of a single scalar root.
That would be incredible unification.
It would eliminate the apparent separation between these fundamental forces in the standard model. And the paper mentions this is backed by further work on gauge symmetry unification via S3 foundation, suggesting they all emerge from an even deeper S3 coherent symmetry. It paints a picture of a much simpler underlying reality.
And this generative power extends to explaining mass, force, and fields, too.
That's the argument. Take mass. The bivector model offers an alternative to the Higgs mechanism. Instead of a field giving particles mass, it proposes coherence localization.
Meaning?
Mass arises when external vector patterns get sort of trapped or stabilized in resonance with the bivector's internal coherence reservoir. It's like a stable standing wave pattern forming within the coherence. Mass becomes a natural outcome of coherence gradients and stability thresholds, not something bestowed by an external field.
So mass is just localized, stable coherence.
In essence, yes, a structured form of trapped energy or coherence. And forces, similarly, are just different ways the bivector coherence reduces into external relationships. Electromagnetism is the U1 reduction. The weak force involves chirality or handedness emerging from the reduction. The strong force is the triadic SU3 expression.
Different flavors of coherence reduction.
Exactly.
Yeah.
And fields themselves, like the electromagnetic field, are seen not as excitations in empty space, but as distributed coherence patterns. What Keeley might call ether stress becomes, in this formalism, structured modulations of coherence across space-time, describable with tensors.
So the unifying thread is that mass, force, and fields are all just different ways that fundamental scalar bivector coherence expresses itself as it differentiates or reduces.
Precisely. It all stems from that root.
Which brings us to the ultimate conclusion of the paper. This idea of scalar neutrality is the universal root of all physics.
This is really the capstone of the argument. It claims that scalar neutrality, that state of perfect internal coherence, which appears as nothing externally, is not an effect or a byproduct, but the fundamental cause, the source from which all physical structures and laws emerge.
So the 0 point isn't just a reservoir, it's the actual origin point.
Yes. Externally, it looks like zero, no net vector, no force. But internally, it's the most complete, infinitely latent state of coherence. It's pure potential, incapable of further decay because it has no asymmetry to resolve. But it holds the potential to generate any external decomposition, any particle, force, or field.
And the universe unfolds from this point, through cascades of coherence reduction.
That's the proposed ontological cascade. From scalar zero-point coherence, coherence reduction generates the bivector. Further reduction leads to symmetry differentiation gauge groups, which then manifest as force and mass emergence, leading finally to the macroscopic world we observe.
It positions scalar neutrality as the universal ontological root of physics.
Exactly. Transforming scalar physics from what some saw as a fringe curiosity into potentially the very foundation of a truly unified theory. Everything comes back to that state of pure, neutral coherence.
So wrapping this all up, what we've really journeyed through today is this proposal by Philip Lillian, the bivector coherence formalism, as a way to completely rebuild our understanding of scalar physics.
Yeah, moving beyond just observing effects, like in the Keeley-Tesla work, to deriving scalar neutrality from first principles, showing how it could unify things like spin, and even the fundamental forces. It's about explaining the deep ontological origins.
And for you, listening, the power of this framework isn't just in the complex physics. It's in potentially providing that aha moment, seeing how seemingly disconnected bits of the universe, quantum spin, electromagnetism, maybe even mass itself, might all be linked through this deep underlying generative coherence.
It really reframes that whole idea of the 0 point. It's not emptiness, it's the source. It's structured, latent potential underpinning everything.
And the paper doesn't pull any punches about its potential significance, does it? It suggests this isn't just another incremental theory.
No, it explicitly positions the bivector coherence formalism as a potential permanent ontological insight. It even uses a eureka scale, comparing its potential impact on our understanding of reality to the impact calculus had on our methods of describing reality. A fundamental shift in worldview.
That's a bold claim, suggesting it could be as foundational as calculus.
It is bold, and it suggests this insight could unlock future eurekas in really practical areas: energy, maybe propulsion, even understanding consciousness. Consciousness is tied to coherence. It talks about paving the way for a potential coherent civilization.
A civilization based on understanding and working with these fundamental principles. It's a truly provocative thought to end on. It challenges all of us, really, to maybe rethink the nature of nothing and see if it might actually be the source of everything.